Hey everybody, how's it going? This is Patrick with Stacking Layers. Today's video, I'm going to be doing an unboxing and how-to setup for the new BIQU Hermit Crab 2. That's right. This is the second edition of BIQU's Hermit Crab series. If you're not familiar with what that is, I did make a previous video, but basically what it is a tool changing system. So it has these different tool plates that you can attach all sorts of different things. So of course, multiple hot ends, but you can also do things like laser engravers or pen plotters, vinyl cutters, all sorts of stuff. Really, your imagination is the limit. But what's really cool about it is that these front plates come off and you can swap them to do other things. It also has two different versions. And as a matter of fact, I do have both of them. So this is the standard version and this is the Canbus version. I want to point out with the Canbus version, it gives you a lot more options, which we'll go over. And this is actually the one we're going to be setting up. But it is limited to Klipper because Canbus is not available on something like Marlin firmware. But if you have a Marlin system, you're not out of luck because this one here is the standard, and I will show you this one first. This one allows you to basically connect like a standard printer, but still have the tool swapping setups. So let's get this opened. I'll show you what's going on here. So in the box, you get everything you need. So of course, you have a quick little pamphlet of instructions. This one has both the Canbus and the regular version. So here on the front here, this one is the Canbus. If you swap it over, it will show you more Canbus. It actually shows you more mounting options. So basically, you have lots of different mounting options, what I'll go over here first. So you can mount to linear rails, which is nice. It covers both the MGN 9 and 12 style, so you're good with that. You also have the option of, show you on the other side, of wheels. So you're not limited to just these fancy printers. If you have a standard, for instance, a very basic Ender, but you want to do tool swapping on that, you can do it. Comes with wheels and everything you need to go, and you can just put your hot ends on there and you're good to go. So it's really nice. All sorts of different belt connection options depending on what you have. So if you have a Core XY or a standard Cartesian style, it's covered. It's a really nice system, actually. I've been impressed with how it's set up. So this is the tool head, or sorry, the carriage and one of the tool carriers. So it comes with 3 tool carriages. So these are what you would swap. So if you push down on here, got a really good hard latch on it. So this part is what your hot end or whatever tool that you're printing on will go on to. And so as you see on the back here, it connects to these. These pins here will connect to those. And basically what it's doing is you have all your input connections. So you have your hot end, your fans, end stops, BL touch, whatever you want, LEDs, all sorts of good stuff. So you got all your different inputs that you can have come in. So that on the basic version will be your standard wire loom that comes in, and then you just make all your connections. And then what it does is it breaks them out to these different points and then sends them forward to the corresponding outputs. So you got your motor, you have, what do you got here? You got your motor, you got fans. On this side, you got your thermistors and hot ends and fans, more fans. You have BL touch. And then on the back here, you got some other things like if you want to do like filament runout sensor, end stop, stuff like that. So it's got everything covered. And really nice with the new version 2 is it has the a few jumpers for your fan control so you can change voltage. So like for the fan 0, you can swap between 12 volt and 5 volts on there. And then you have the other ones that you can go between 12 and 24 volts, or actually 12 and 24 on this one, and 12, 24 and 5 volts. So there's a couple little different power regulation systems going on inside there. So, you know, it's really nice to have the option to be able to swap things around. So basically how you would set this up is you would remove this plate and then put your tool on, depending on what kind of tool. So for instance, here I have an H2. This is the H2 version 1, and this is all set up on one that I've been using. And as you can see, I've just brought in, like, I got the heater cables, the thermistor, 2 different fans, and my micro probe, the BIQU micro probe. And that's what I've got hooked up to that. Oh, and of course, the motor. This is a direct drive system, so you got the motor in there too. So all the different things are already plugged in here, but as you can see, it's a standalone unit. And then this part is what would be on your X gantry. And then you would basically just snap it in. And you're good to go. And then you can print. So it's really nice. It's a really great, easy system to use. So let's see what's in the box here. Like I said, it comes with everything that you need, but I just decided to go ahead and show you what's in here. So let's get this aside. All right. So right off the bat, of course, you get your little rubber ducky. BIQU's and Bitrate Tech's little trademark thing that you get a lot with a lot of their boards. I still don't know the full story behind these little guys. Something to do with the owner or the founder of the company. Some sort of personal thing about it. I know there's rumors about it having to do with something with coding. There's some sort of rubber ducky thing about coding. I forget exactly what it's about, but I don't think that's what it is. From what I've heard from rumors, it's something to do with the founder. Anyways, so you got a sticker. You got your extra tool heads. As you can see, I've already opened this and struggled to get this box out. Their packing is very tight and nice, which is a little annoying to get it out, but actually really nice when it comes to shipping, so you don't have things flopping around. But let's just get all this stuff out. There. Okay. So in this one, we have all the cables that we need. And I'm not joking when I say all. It is, as you can see here, it comes with loads and loads of cables. So you got things like for a BL Touch or microprobe, you have end stops and you have motor cable connections, and then all the looms. Basically, this is the whole junk that goes over to your printer. So this is a standard printer setup. So that's why I'm saying, like with enders and all that stuff, you have all your wires that come up. That will connect to all this stuff. So you got your fans and your motors and all sorts of things that you would need to use to plug into here. That's what that is. So you don't even need to worry about re-crimping and all that stuff. It's all done for you, which is really nice. So this is the basic connection. And I want to point that out because this is the reason why a lot of people are talking about Canbus now. You know, all these wires. Well, Canbus is going to make all of this down into one. I have a cable down here on the side that I'm going to be using for demonstration. It comes into one loom. All these wires through Canbus are handled with this. So you got your power in your Canbus. And that's like I said, what we're going to be setting up. But anyways, it's not a bad thing. Like I said, if you have a basic printer, you don't have a Canbus or Klipper setup, this still works perfectly fine. This was actually my original H2 that I was using. Sorry, the Hermit Crab that I was using was with that setup. And that was my very first one that I set up, and it worked great. That was way before I went to Klipper and started doing Canbus and all that good stuff. So let's pack all this back up real quick. I'm not a packing engineer. Pretty impressive what these people do when they pack stuff because they get so much into such a small space. Okay, in this little box, we have hardware, which is really nice. You got tools for doing things, little screwdrivers and wrenches and some zip ties. But then you have this stuff. So you don't even have to use your existing wheels. You have all the wheels, everything that you need. Different options for belts if it's over or under style belts. Screws, everything, eccentric nuts. So it's really nice. You're good to go with everything. I was a really good surprise to see that they supplied all of that stuff, because typically it's more traditional. You get the plates, but you use your existing wheels and stuff from your printer. So that was a really nice thing for them to send extra stuff, because sometimes you just don't have the right size or there's a slight size difference. So it's really good to have that. So let's get this one packed up and then get to the Canbus one so you can see what's in there. There we go. Make sure I got everything. All right. Okay, so here is the Canbus version. Let's get this open. And as you can see, still comes with the same instructions. It's the exact same pamphlet, so nothing new there. Overall, it looks the same. You got your 3 tool plates, got your duck. This one comes in an extra sticker. So you got the the Klipper sticker down inside, if I can get this out of the way. So you got your BIQU and Klipper sticker because, again, Canbus version is only available with Klipper at the moment. As you can see, it still has the same type of release feature. You press down on the plunger and it releases the tools. All the tool sets are the same. Really nice. They're completely interswappable with the standard and the Canbus version. So your tool plates are identical. But as you can see here, the carriage part is actually very different. A lot more going on here. So basically what you have here is a miniaturized motherboard, easiest way to say it. This is your MCU. So this is what is your full controller unit for the hot end. It does come with the TMC2209 stepper driver. The main MCU, the controller chip, is the Raspberry Pi RP2040 chip. Really nice chip because it's easy to program and works really well. And it's very compact too. But then you also have things that are really nice, like you have a LIS2DW chip in here, and I believe that's that little guy right there. But it basically you have accelerometer built in, so you can do all your input shaping and stuff like that. You also have the Max 31865, which is the PT100 converter chip. So this allows you to use both standard thermistors, the traditional, glass beads or whatever style transmissions, thermistors, and you can use PT100, PT1000 with a higher, range of temperatures and more sensitive temperature readings and stuff like that. So you get all that covered. You have, what else do you have on here? You got, your microprobe stuff. You have some LEDs, some RGB LEDs that you can control. All that good stuff. You also have a temperature sensor on board, so it can read out your temperature of the board. So everything's covered on there. And like I said, all your stuff comes through from the hot end, from your motherboard. And with this, which is nice, is the Canbus. It is only those cables that you need. Let's grab that thing over here. So this is the other end. And so you have your power and your Canbus signal. And these two little guys here are what are driving everything. So basically what's happening is, if you're not familiar with Canbus, when you plug it in, it gets powered up, of course. So that's going to give you power for not only the board and all that, but also for your hot end and motor and all that good stuff. But then the Canbus tells this guy what to do. And this one is actually in control of all the things that are going on. So this is just, the Canbus is really nice because it's only sending the signal telling him what to do. Whereas the old style is sending the individual signals to every single one of the different things. So your fans and your hot end and all that stuff. And so each wire has its own connection, whereas this one is a group communication. That's why Canbus is so much nicer and really good, is that it's very compact, because this is all the wire that you need to come to your hot end. No more of the giant loom. So that is the gist of it. I'm not going to go much more into all the hardware stuff. What we're going to do is set this one up so I can put this aside. But let's get inside the box too, just so you can see a quick little what's inside. Really, when it comes down to it, it's the same. I'm not going to open this one because it is identical to the previous one. This is going to have the wheels and your tools. This one is a little bit different because, of course, it's a different cable. So you still have the little cables, like you can see inside. So you got your BL Touch and your motor cables, but then you have the bigger cable. So this is your Canbus cable. So you have only 4 wires, power, and Canbus. One thing I want to point out, if you haven't seen my videos before, I gripe about this all the time. These have soldered tips. Get these off. BIQU, if you're watching this, Big Tree Tech, any other printer companies, stop doing this. Again, I know I say this on a lot of my videos. Just don't. Put furls on there. Also, this is too short. This is a very short connection. I know they have a new board, I think, that has like a new way of connecting power, but this is too short. It needs to be a good length. So we're going to have to cut this out. And I've done that already on the previous wire that I have. But I recommend, if you guys get this, anytime you see power cables that have solder on them, get the solder off of there. Remove, just cut that part off. Bare wire is better. But even better than that, you can do furls. There are those little caps that are going on the ends. I think I have them on here. These are furls. Those are the best things to use because that crimps it, keeps it a hard, solid cable, and it gives you a good solid connection. The problem with the solder is that it will droop over time, or it'll start basically flowing slightly. It doesn't go liquid, but it does over time under pressure start to open up, and it can crack and things like that. Basically what happens is you get small gaps, or you'll get basically a loose terminal connection. And what that does is it causes the terminal to start heating up. It will not trigger a fuse or anything like that because it's not drawing too much amperage, but it's causing a resistance there at the terminal, which will cause heat, which will eventually melt, or worst case scenario, start a small fire on your system. So at the very least, if you don't want to touch these things and you want to use solder, occasionally open your machine and then check to make sure that your terminals are not getting loose. Because that is the number one. If you ever follow the communities around and you see people talking about their burnt connections and you see them melting down and wondering why it didn't go away and what cheap everything is, it's not that. This is what's going on. It's causing a loose terminal, which will cause resistance and will heat up without triggering any sort of thermal protection and without triggering or blowing fuses, because it's not actually drawing too much amps. All right. Safety announcement, just take care of that. Really easy fix. Clip it off if you don't want to do furrows. Bare wire are best. Get a good solid connection. Make sure your terminal screw is screwed down nice and tight. Of course, don't overdo it to where you break the terminal, but make sure it's a good solid connection. So that's enough of that. Let's get this thing programmed. But of course, before we go into that, I want to give a huge shout out to my channel sponsor, PCBway. They've been a huge help keeping my channel going, and I have to can't thank them enough, actually. They're really great people to deal with, also really fun, really down to earth, easy to work with. So if you're looking at getting any type of PCB stuff made or CNC stuff, maybe you want to get some custom tool heads, tool plates made or something like that, you can do that too. They do all sorts of fun stuff. So check them out. Here's a quick video and we'll be right back. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBway. PCBway isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBway has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBway takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBway offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBway services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBway for sponsoring this video, and now let's get back to the video. Okay, so we have the tool plate. Let's get this thing programmed. I'm going to be installing, of course, Canbus. I'm going to be installing Katapult, which formerly was Canboot. That's been changed. The name's been changed. And the reason I recommend installing Katapult is because it makes it easier for future upgrades. This is not a requirement. So if you want to skip the Katapult thing and go directly to the installing Klipper version alone, the Klipper firmware, you can do that. The disadvantage is that if you want to update your Klipper firmware, you will have to, again, take the system off, plug into USB, and basically go through the basic part of getting everything installed manually. Whereas with Katapult installed, you can do everything from command line. You don't have to remove anything from the printer. You don't have to push any buttons or anything like that to put it into boot mode. So it really is a nice, convenient way of updating the board. And that's why I recommend installing Katapult. Otherwise, it's really not required. But that's what we're going to do today, okay? So let's get going. I am going to be using the BIQU Pi that I've been using for most of my tutorials. I will also have, just because, I'm going to have the SKR Mini E3 V3 board that I normally do my tutorials with, also just so you can see everything cooperating together. But we're not plugging any of that stuff right now. Right now, all we need to get started is a USB-C and the Pi. So let's get over to the software side of this. So let's see, first we can go over to here, and this is the Katapult website. So it's GitHub ArcSign Katapult. I'll put the link in the description, of course. And this is what we're going to be using. Now, as you can see, it was formerly known as Canboot. So if you're familiar with Canboot, this may be really easy and familiar with you. Most of everything is the same. It's really just a name change. So that's why people get confused. Where did Canboot go or stuff like that? I think I could be completely wrong, but I believe what happened was there was so many people thinking that Canboot meant that this is only for CAN bus, but it's not. It can be both for USB or CAN bus. It was just meaning that I can boot, basically. I can boot without needing any special buttons being pressed or anything like that. And that's what it is. I can boot. But so I guess that's from what I've read, that he changed the name, the developer changed the name to Katapult to get rid of that stigma of that it's only for CAN bus. This is a really great tool. But first things first, what we need to do is come and down to here where it says building, because we're going to need to install. If you don't have this already, you're going to need to clone the directory, and we're going to be using that. So we will get now into Putty, which is my favorite go-to SSH, the Secure Shell program. So this is, if you're not familiar with Putty, you should be, because this is what a lot of people use when it comes to doing these things like installing Klipper. It's also what I've been using in most of my videos. So if you've been following along so far, you'll notice this, but I'll put a description or a link in the description also to download this. But all this is a TTY communication system. So you can do all sorts of stuff like which we're using for SSH, serial communication, all good stuff. So it gives you a way to communicate with other devices. But we're going to be using it for the, obviously to communicate to this guy because I don't have an interface here. So we're using the computer for that. So I already have it set up. I'm going to just double click here because it's a little bit bigger text and stuff. But what you would normally do if you're brand new is you would come into this area and type in the address, like, 192.168 and so on. So it depends on whatever your IP address of the device that you're connecting to. That's what you would put into this field here. Okay, but we're not doing that because, like I said, I already have one loaded. So I'll just open up that one. Oops. I have to load that up. Let's open it back up. Okay. So click there. There we are. And the reason why, like I said, I'm using that is just because I have giant text so you guys can see better. So we got to log in. This one is just the traditional BIQU. Oops, too many characters there. Okay, so we're in. So like I said, we first need to come over to here. What we need to do is go ahead and get this first thing. Sometimes you can copy it all once just by clicking this. It'll copy everything in this box. But that does sometimes run into errors because it does things incorrectly. So just do a one line for line. So go ahead and copy that. And then we come back over to PuTTY and right click. This is another reason why I like to use PuTTY is for copying and pasting. It's really simple. So you copy from your source. And then when you come over to PuTTY, you just hit the right click button and it copies right in. As you can see, I did twice there. Okay. You don't want to hit Control V. I'll show you basically what happens if you hit, I'm sorry, Control V. It does nothing. And then if you come in and right click again, then you get all these weird characters in front. I honestly, I can't remember why that is, but that's just something that Linux does. So don't use Control V. Backspace all of this. You can do Control Shift V. That sometimes works, but it doesn't. There it goes. It makes those weird characters again. So the traditional copy paste things don't work, but with PuTTY, if you just right click, it'll pop it in. I just want to point that out because I do see people, sometimes they ask me what's going on, this isn't working. And I've seen what they've done is they've just did Control V or they've done some sort of weird pasting in and it has those extra stuff. And that's why the commands aren't working. So anyways, let's do this. We'll hit that enter with that. Oops. Katapult already exists. Oh yeah. Here, let's just completely remove that so you can see from scratch. Command to remove things. We have, if I can remember this, we got sudo, just giving a super user. And then we want to rm is remove. And then because it's a directory, we do r. This has nothing to do with installation. It's just because I want to show you how to remove, or I want to show you from scratch what it looks like. So I'm removing my directory. Remove Katapult. So it's removing everything in that directory. Okay. Now, if I put in this link in, no, I put this in. Okay. Input, enter. This is what it's going to do. So it's what it's doing is downloading that repository. Basically, if we come back over to here, it is downloading everything that's here. So it's all the good stuff that you need to get going. So once it's done, everything is good in there. You can check with the command. Oops, get back over here. Command ls is list. It's list everything that's in the directory you're in. And as you can see here is Katapult. Then you can go into that change directory, cd to Katapult, and then ls again, and it shows you everything that's inside there. All right, so that's what we're going to be using, and you do actually need to get into Katapult. So that command right there, cd Katapult, gets you into the directory. And so the first thing we're going to need to be doing is making the firmware for the board, the Katapult firmware. It's going to be a multi-step process, but stick with me. It's going to be pretty easy. So the way to do that is you want to do a make command. Now make sure you're not in Klipper. You have to be in the Katapult because we're making Katapult firmware. We're not making Klipper firmware right now. So just make sure, I want to point that out. So we do the simple command of make and then menu config. And that, oops. There we go. make menu config, and enter. And this is going to bring us into the menu configuration of basically the firmware making. It makes binaries for the firmware for the chips. And as you can see here, it looks just like, if you're familiar with the Klipper, you should be if you're going this far. It looks like it, but except for this on the top here, it is Katapult configuration, not Klipper. All right. So what we need to be making here is the firmware for the RP2040. So as you can see here, it's on a different processor module. So you want to go into there, and the way to navigate this is up and down arrows, and then using spacebar or right to go in. Spacebar selects, or right just goes the same thing, goes in. And then you use the left arrow to go out. So what we need to do first is come into here, microcontroller architecture. This is what type of board we're going to be using. So we're using a Raspberry Pi. So you hit spacebar, that selects it. And then the chip, you just want to leave it default with that. And then the Katapult deployment application, this is so it deploys updates and stuff like that. So you want to do that. The 16-bit kilobit bootloader. And then with the communication interface, we're not doing USB, we are doing Canbus. And then the Canbus pins, you leave the default. This is very important here. This is the Canbus speed. I'm going to show you why that's important on another area. There's one more thing we need to set up for Canbus before we get too deep into this. But this here is the bit rate. I recommend, in a previous video, I recommended to use 500,000, and that was pretty good in the past when I made that video, but that was kind of outdated now. And especially if you're using accelerometers, you want to use a faster bit rate. So just stick with the new recommended 1 megabytes, the 1,000, 1 megabyte bit rate. Okay, so the important part is that anything you do with Canbus, any settings you set with Canbus, that needs to match the same bit rate. If it doesn't, there's going to be problems. You're going to get communication errors. So that's one thing I need to really stress, is you have to have the same bit rates overall. So keep it at 1,000 and you're good to go. You hit Q to quit and yes to save. And there's really nothing going on. So the next part, what you want to do is to make the firmware. So I always just recommend to make clean first. On a brand new installation, you really don't need to worry about that, but I always recommend to do it just because this will clean out the folder, the directory, same thing, but it cleans out the area where it's going to make the binary. So just in case there's anything left over, if you already have done this with other boards, it can leave some artifacts in there that may get put into the binaries that aren't supposed to be there. So it's just a precaution. And then the command to make the firmware is as simple as just make. You're just calling the program to do its job. When you hit make and hit enter, it's going to start doing its thing. So I'll fast forward through this. Okay, now that that's all finished, the next thing we're going to have to do is install it. And there are multiple ways of doing it, but I'm going to be showing you what I feel is the easiest way. It's going to be using, the terminal here that we're still in. But first, we have to do something to get the board into a mode to actually accept this file that was made. And what was made is all sorts of stuff here that was made, but the specific thing that we're looking for is, where did it go? This one here. This is the UF2 file, the Katapult, and it's in a folder called out. And we're already in the Katapult directory, right? So if you just do ls, you'll now see that there is this out folder directory. I keep saying folder, same thing. In Linux, called directory. So you have your out directory. And if we go into out and list again, ls, you'll see you have all that stuff. That's basically everything that's going on. So the files that we're going to be using, or that's going to be flashing, is this guy here. That's kind of a specific file, a firmware install file for the Raspberry Pi. I want to point that out because you can get into this folder and there's an alternate method of installing things, and that is to download this file from your host computer, from where we've built this, onto a standard PC. And then you can do what I'm going to show you here in a second with the board. Then you can put it into the boot mode, and it'll show up as a hard drive or as like a flash drive on your regular PC, and you would just drag and drop this file onto that. It'll automatically reboot and install. So that's another way of doing it. It is just as easy, but it's an extra step. So you have to have another program or some other way of knowing to get this file off of the host computer or your little Raspberry Pi and put it onto your main computer that you're going to be plugging into. So It's just an extra step, and I feel it's not necessary since we can do it all in one here. And that's what I'm going to show you now. So let's get back to the Katapult. So cd ... that takes you back one directory. So we're back into the Katapult directory alone. And before we do any more commands here, I have to show you on the board how to get it set up into boot mode. So we have the board not plugged in. First thing we need to do is use the USB cable. We're not doing Canbus yet. This is to install the Canbus firmware, basically. So what we're going to do is there's this little button here on the side. That's your boot button. And that needs to be held in. So this is the same method if you're going to be doing the drag and drop I just described onto a regular PC. But you hold this in, and as you're holding that little boot button, and keep holding it in while you plug in your USB. Let's see if I can do this one-handed. Go, it powered on, and then once it's powered on, you can let go. And now it should have. With the Raspberry Pi or those type of things, you don't get any kind of audio or visual feedback. But of course, if you're on a regular computer, you'll get the USB. If your sound is on, you get the USB sound being plugged in, and then you'll see it pop up as a new flash drive. But here, obviously, nothing happens, so we need to come back to the screen and make sure that it actually did boot correctly. And the way to do that is you type in the command ls-usb, all one word, hit enter. And if you see this line here, Raspberry Pi RP2 boot, that's good. You're in the right area and everything is good to go. So now we have to run the command. Very simple command. We're using the make that we did, not make menu config, but the make program. And then we want to now flash. And then the next part has to be all caps. That's flash _ device. And of course, this will be down in the descriptions. The description, I only have one. Flash device equals. And then what we need to do is get this ID number. So we're telling it to flash to this specific device. Most time, this is going to be the same number, regardless if it's mine or yours. I think that's just kind of the default number for these chips. But make sure that it's the one that is, yours. If you have multiples and you're not sure which one it is, you can unplug it, run the ls USB command again, and see what disappeared and what comes back. So if you have multiple Raspberry Pi for some reason in boot mode, it could possibly have different ID numbers. I just want to point that out. But most times it's going to be that. So again, a feature with PuTTY, why I like using it, is if you highlight it, it automatically copies whatever's highlighted, and then you just right click, and just right click, and it'll automatically pop that down to wherever the cursor is. That's a really nice handy feature. That's one of the main reasons why I like using PuTTY for copy paste. Do not use the Control-C, Control-V, because that's just going to mess things up. So here, that's all you need. You need that full command. And then if everything is in the right mode, you hit enter, it should flash over. There we go. Really quick and easy. It's a very small file, so it doesn't take much time to flash. But it does. It finds the file that it needs to flash. It finds the device. And then it goes ahead and does its thing to erase and flash and reboot. So now we're good. If you use the ls-usb command again, you'll notice that it's gone. That's because it rebooted itself. So you don't even have to unplug or stuff. But you can if you want. Technically, we don't need it in USB anymore anyway, so we can go ahead and unplug that. So the next step we're going to be doing is querying, but there's a couple things we need to do. Set up Canbus, of course, is the most important thing, because if we're going to communicate to Canbus, it needs to be running and set up. But I want to point out first, let's go back over to the hardware here. So this board I'm using, I have the additional Canbus is the U2 USB to Canbus adapter. That's specifically for this Pi board. So that's on there. This is what's making the Canbus signal available. And it's broken out. It basically does its thing and it sends it over to this header pin. So that's what I'm going to be plugging into. But there's other options. So I have, for instance, an older Raspberry Pi here that has the original Hermit Crab Canbus Pi hat. There's also other Canbus Pi hats that you can do. So that's an option. Same principle. It's just outputting through a different output, but it is Canbus there. Then there's also all the new like Manta boards and other controller boards that have Canbus built in. So there's different methods. Depending on what your board is, you're going to have to find which one has what kind of system it needs to run for firmware. But most of the time when it's with these Pi stuff, it's pretty simple. You just plug in and then do a couple commands here. And I'm going to show you the main one that's very important one that a lot of people overlook is setting up your CAN0 interface. So let's get back to the screen here. Okay, so what we need to do is get into to check to see if your Canbus is set up to work, basically communicate. And the command for that is to, well, we're going into a folder check. So we just do a sudo, that's a super user, oops, not caps. Only use caps when it's absolutely required or in the name. Linux doesn't like, they're very case sensitive. So you point that out. So we got sudo, this is using as a root user. And then we're gonna use a program called nano, that is a text editor. And then the file that we want to edit is in etc directory, and then it's in the network directory, and it's called interfaces.d. That is the interfaces daemon. And then we want to check for a folder called a file, can0. Can0 is the most commonly used name for CAN bus communication on interfaces. Interfaces are things like network interfaces. So, you know, your wireless, your Ethernet, all that good stuff. CAN is a network interface. So you hit enter, and what you should see is something like this. It should, like for instance, all the BigTree tech stuff, I think now comes, if you use their stock image for their devices, it comes with it already plugged in. And I think a lot of the Raspberry Pi stuff is now doing it too. But if not, if it's blank, this is what you need to put into there. I can't remember if it's vital that this indent is on these two lines, but I've always done it and I've always seen it put that way. So it might be. I've never really cared to look, see if it is, but make sure it's just set up that way just in case. Sometimes these codes, they do need indents in order for them to work right. So basically all you're doing is allowing a hot plug on can0. This is the name. It's not basically just CAN bus. This is the name that's using, but it's using a hot plug, meaning that you can, if it loses power or connection, it'll automatically reconnect, things like that. So you can unplug it and plug it back in and it'll do its thing with CAN bus. And then it's doing an interface name. It's basically saying which interface. It's set up can0, a name of can0 on a can of a static CAN bus. And then the bit rate, this is what I was pointing out earlier when we made the firmware. It has the bit rate of 1 megabit. That's the 1,000,000. That is vital. This must match. Basically everything, all of your CAN bus geared items must have the same bit rate. The same thing as other things like serial communication. If you use a certain serial communication bit rate, they all have to match in order to talk. Otherwise, they're speaking a different language essentially to each other. That's important. So just go, I know in previous tutorials, I did one where it was 500,000. That was back then, that's what I was using and it worked fine. But the reason why you use a faster bit rate is because of accelerometers, for instance. They transmit a lot of information at once. So, in order to get a good clean transmission, you want to have a faster bit rate. So that's what that is. And then basically this next line here is turning it on. So up means to activate the interface configuration. So it turns it up or turns it on. It'll say down as off. And then it's setting up a transmit queue length of 1024. There's other tutorials that show it as something like 128, or some are bigger. I know, I think on my last long time ago tutorial, I'd had a 248, which is a lot of information. It's not really necessary. This is a good number I use if you're having problems with transmit, too much information, or you're getting like errors. You can bring it down. Normally you would want a smaller transmit length, as if you have a lot of things going on and there's some noise on the line, things like that, and you start losing packages. So you can drop down the transmit so it's smaller packages that it sends out at once. For me, this works perfect. I've never had any issues, so that's why I like to use it. So make sure that's all in there. And then when it is in there, I'll just make a little edit so it has to show what goes on. So basically, if this was blank and you populated that in, you're going to have to save it. And the way to do that is Control X, which you can see down here says exit. So quick little what's going on down below here. These upticks, those little arrows pointing up, they call the caret. That means control key. So it's Control and X does exit. Control G gives help. And then there's other ones that are with M over here. M is the Alt key. So Alt, U will undo and things like that. In here, if you notice, or you probably don't hear me clicking, but I'm clicking with my mouse and it doesn't do anything. This is all done with the arrows. So it's full on arrow, no mouse stuff. There is a way to set that on, to turn it on with mouse in the settings here, but it's with the arrows. So if you need to edit anything, you use the arrows up and down, left and right, and whatnot. Okay, so pay attention to that. You can't just click and start copying and pasting. So anyways, to save, you hit Control X, It'll down here ask you if you want to save the modified buffer. You say yes or hit Y. And then the next thing it'll come up, do you want to write it to that? Yes, we do. Hit enter. And we're good. It'll back out. All is done. If it was blank, you do need to reboot right now. If you actually was the first time making that file, you need to reboot. Otherwise, that file won't be activated. It activates at boot. So go ahead and reboot if it was a complete blank file that you just now made. Otherwise, if it was already there and you just hit Control X, it would automatically just pop right back out. You won't have to save because you already made it. And then you get back in here, you're good to go. But now what we have to do is actually plug in the CAN bus before we query to see if the CAN was actually set up. So let's get back over to the hardware. And like I said, I did already make a cable. So I got this. This is from one of my other CAN bus devices. I'm just using it since I use it with this Pi. So these are the two ends, otherwise it's a long cable. This is going into the Hermit Crab, and then this is going on to the CAN bus. So like I said, these two are the power, and this is the CAN bus. Yellow is high, green is low. So far on all the Big Tree Tech wires, that's what the color combination has been. So it should be that. That's pretty typical. Yellow is normally high, green or some other color is low. Sometimes I do like a white and a gray, but anyways, that's a very common color scheme. But with Canbus, there's no worry. If you do reverse, it's not going to burn anything. It's just not going to work. It's just, you just flip the cables around. So if you're having communication issues and it's everything's powered up and you know the things you're not getting any type of communication, you can try swapping the two wires on the Canbus signal and see if that brings it up. Another thing is with termination resistors. There's this little guy here. It's a 120 termination resistor. You have to have termination resistors on both devices. The first, sorry, if you have only two, it's gonna be on both. If you have multiples, it's the very first, so the far left and the far right, the ends of the Canbus line have to have termination resistors. So on this one, the termination resistor is right there. So since I'm only gonna have two devices, the transceiver and the Hermit Crab, then everything is good. Both of them are terminated and they're good to go. If I have one more, then the center one, the one that's in between the first and the last, does not have any termination resistors. You don't need it. Only the first and only the last. Okay. I want to point that out because that's another issue I've noticed a lot of people run into. They don't get a communication, or they get a partial communication and then all of a sudden they lose communication. It's because it's missing or has the jumper in the wrong zone. And keep in mind that some of these type of boards, this one doesn't, luckily, but some of them actually have a built-in resistor. So you got to be aware of that. Look in the guides. And if it says that it's a built-in resistor, then you have to make sure that that one is a first or last device for connection. Otherwise, that can cause problems also. Anything that's after the resistor is not going to get a clean or, if any, communication information. Okay? So these resistors are important to have on the first and the last device. So obviously we got power and Canbus. So I got just a little dinky power supply I'm messing with here. So let's get that put in. Now, I don't recommend doing hot booting, or sorry, hot plugging of anything. Basically, don't do that, because it can cause issues, especially with fans, motors, things like that. Never swap or unplug or plug in devices like that have induction loads while it's powered up, because that can cause issues. It can actually dump a lot of amperage into, or a lot of voltage into your system. So anyways, so I got my Canbus line plugged in. Like I said, it's using this special little adapter. Sorry, it's not really on screen, is it? Got that plugged in there, using this adapter to talk to that. That's plug in your Canbus. And then the other end gets plugged on to the board. And there it is. So if you notice, USB is not plugged in anymore. Light's coming on because I got power coming through here and Canbus signal coming through there. So that's all good. No buttons you need to press. Basically, that's the setup ready to go with Canbus communication, as long as everything flashed and worked correctly. So let's go and query to make sure that actually did work. And the command to query is, there's actually two different ones you can use, but since we're doing Katapult at the moment, I'll just show you the Katapult one. So what we need to do is get into the scripts directory of Katapult. So again, make sure you're in Katapult. If you're rebooted, you have to do the full CD first, Here, I will back out so you can see all the way. This is the home directory. All right, we're in there. So we want to first get into Katapult directory and then into the script. So cd / or not / cd Katapult. I can type, and then scripts, and that hitting enter will take you into the scripts directory. There we are, Katapult scripts. All right, because in here we do ls list. We're going to be using this Python script to query and later to flash the device. Let's query it. To query, we have to, like I said, it's a Python script, so we have to call Python. And normally it's Python 3 is what is installed on all of these now. If Python 3 gives you an error, you can just do Python instead. Python 3 is pretty much what's used these days. We do that, and then we want to tell Python to use the flash tool, Python script. And then in the Python script, when that's running, we want to first do look at an interface. It's the -I command. And we're saying, okay, look at the interface of can0. We're saying, look at can0, see what's happening there. And then query -q is to query what's on that line. Show me who's there, what's going on. And let's cross our fingers, everything worked out correctly. We hit enter, and it should run the script. And there we go, it did. It runs the script, it resets the bootloader and any node IDs that are connected. And then it looks for any type of Katapult nodes, and it found it. So this is found a UUID, and this is the specific number for our Hermit Crab, not for yours. Every single board is probably going to be the same, or sorry, different. Every board will be different. Make that correction. Every board will be different, so do not copy mine because that's not going to help for you. But run this, and you should see something like that. If you're not getting a UUID, if it just says query complete and there's nothing here or some sort of error or something like that is not able to read, go through the troubleshooting things first, okay? So let's go back to the hardware. Again, make sure that your jumpers are fully in place in the right areas. So I have both the 120 resistor jumpers on the very extremes. If you have multiple boards, like I said, in the middle, that one does not have a jumper on it. It should not. Make sure that that board doesn't have a built-in one also. I'm pointing at this board. This has nothing to do with Canbus because it doesn't have that, but as a demonstration. Other things to check, if you see that all your jumpers are in place, you have power, things seem to be plugged in right, you can try swapping the cables here. Like I said, it's not dangerous to flip the Canbus cables. Don't swap the power, of course. But the Canbus can go. So it may just be that the high is on the low side and vice versa. So check that, see if that fixed it. Run the query again after swapping that. If not, if that's seems all good and you've swapped the wires, no change, double check that transmit, that bit rate, that it's matching on all of them. So like I had the 1 megabit, the 1000 bit rate on all of them. If you have a third board, if that one has a different bit rate, that can be causing problems, all that good stuff. So that has to match, okay? That's why I say it's vital, because you will have communication errors if it doesn't. So let's get back over to here, because I'm going to assume that everything worked out good and you got your UUID. First thing I want to point out, it is vital to copy this and paste it somewhere like on a notepad or somewhere else where you can keep it, because this will disappear when Klipper connects. So as soon as we get Klipper installed and everything is good and Klipper communicates, it will no longer let you. Klipper does something where it hijacks the query and it won't show you this anymore. So keep that in mind. You need to copy this. It doesn't go away per se. It's still the ID that you need to connect to. It always is going to be the chip ID, but once Klipper connects, it's gone, and we actually need to use this to flash updates and things like that. So it'll be hard to get it again. So copy and paste it onto a notepad or somewhere safe so you can always reference it. So after you do that, now we need to install Klipper, because as you see, this is saying application is Katapult right now. So right now, what's on the board is only Katapult, no Klipper. So Klipper doesn't know how to talk to it yet. So the way to do that, we need to get to our Klipper directory now. So if we do cd and enter, that'll take us back to our home directory. And then we want to get into the Klipper directory. Do cd, Klipper, enter. Now we're in there. And here we're going to do the traditional Klipper programming, or sorry, Klipper firmware make. So the make menu config, enter. And this will pull up like we saw earlier, same kind of thing, except for now we are in Klipper firmware configuration. So, oops. In here, we want to make sure that things are enabled. Now, I've already gone and done it with this one, of course, but if you see something that's pretty basic, like you don't see extra stuff, you go ahead and enable. Normally, I think that's enabled by default now, but if this is your first time in here, go ahead and enable that. Come down to the microcontroller, make sure that you're in the Raspberry Pi 2040, the one that's highlighted here. If you had something else like like my SKR Mini, then it'll be on there. If that was the last firmware you did, make sure you're on this one. Hit spacebar to select it. This, we want to make sure that we do have the bootloader offset set, because when we installed the the Katapult firmware, it is actually a bootloader system. So we want to not overwrite that bootloader. So go ahead and give that bootloader there. Then we want to do the communication interface. Of course, we're using Canbus. So none of these other ones. Don't use this one. This is for a different type of Canbus system. We're using Canbus. And everything else stays the same, except for that. Make sure that it is at that number there, or whatever it is that you chose to use. This is, again, that vital thing for communication. I can't stress this enough. I see so many people having problems, and it's just because they had multiple numbers used for that. So like they forgot a 0, for instance, and it won't work. Make sure that's right. And then you want to go ahead and hit Q to quit. And then I don't think it's going to show me because I haven't edited anything, but you do Q. And if you get a message again, it says Y. So you have to save it. Yeah, it actually did for me. Good. So do that Q and then Y, and then it backs you out. So it saved it. Then we want to do a make clean again, and then make. There. And I'll fast forward through this because it's going to be the same thing as what we saw earlier. Now that that's finished, we get to install Klipper firmware onto our board. Like I said, we're going to be doing this via Canbus. So this is going to be the new thing. This is why I like using Katapult to do flashing, because this is going to allow us to do everything from the terminal, make it really easy to accomplish. So first, what we need to do is not be in the Klipper directory. We need to get back to the Katapult directory. CD just to get back out. And we want to CD again into Katapult. Hit enter. And then we want to get into the scripts file. So we're going to be using that Python script again. So now we're in that directory. What we're going to be doing is running that Python script again. Let's just do the ls so you can see. We're going to be using the flash tool again. But this is going to be a little bit different. And this is where we're going to be using that UUID that we copied. So again, it's the Python. We want to call Python. When I say call, that means to activate. And then we want to use the flash tool script. And then we still want to do the same thing where we're using the interface of can 0. And then we want to, this time, instead of query, we want to do -f for flash. And then we tell it the file. Now the file where we're flashing is over here in the Klipper directory. Actually, what we're going to be doing is flashing this file here. This is the Klipper firmware file, and it's in this folder. But what it is, you see it says out, but of course that's in Klipper out klipper.bin. So the way to do that is we use the little squiggly mark. So you got to find that on your keyboard. It's the little squiggly that you'll see in a second here. Well, normally I want to point out when you press that key, nothing happens. You have to do the next character before it actually pops up. So there it is. Now you see both of them did. So it's that little squiggly character you're looking for. This is basically just telling it to go to the home directory. So when you see that, see here, is that squiggly line? It's saying it's your home directory, and then the directories within there. So just want to point out, because that's something I've noticed some people, they try to run this command, but they forget that little thing there, and it gets a failed command. And so if that squiggly is not there, it could be causing that problem. You could also go through and do the whole thing if you do something like / home, do your username, and then Klipper, and so on. You can do it that way also. That's another way of doing it instead of doing home. But basically, if you just do the squiggly and then get in, that's basically right into all the other stuff. We want to get into the Klipper, and we want to get into the out folder. And then the file that we are flashing is klipper.bin. A little bit more we have to do. we want to tell it to go -u. That's to what UUID are we flashing this to. And that's why we need to save that UUID from earlier. So if you want, if you're still on the screen, you haven't rebooted or anything like that, you can go back up to where we queried. So you can highlight it. Again, this is a putty thing. Highlight it and right click. And as you notice, it popped it right down below. It's a really nice handy thing. So this is how we want to do it. So quick breakdown so you know if you have any problems and what's going on here is to check if you're missing something. So we're calling Python. Python run something. And then what do you want to run? I want to run this Python script. And then I want to check the interfaces of can0. So basically flash tool, look at can0 and flash this file to this device. Okay, that's the breakdown of what that script, what that whole command is doing. And then when you hit enter, again, if everything is working right, you're communicating good, you should see something like this. And it should boot and flash. So it reset jumpers. It basically, over the Canbus line, was able to press the boot button in a sense, and then put it into boot mode, flash over the firmware. It checks it, make sure everything is successful. You get this long number, which basically is its way of confirming that the file that was sent to it matches the now file that's sitting on the system. So everything is good. That's what the SHA, it's a hash code that basically it's a code that's automatically generated from all the bits of information that's on a certain file. Kind of an interesting way of confirming that the files match, no corruption. And so you get that flash success. That means we are good to go. We have now put Klipper on that. And of course, we can check that. We're still in the scripts here for Katapult. So let's use the Katapult query script again. You can use Control R, and that will allow you to search. So you can, search things that you've already typed. So here we have the flash thing that we just did, and we hit Control R again. It'll go through everything that matches. So I just hit Control R and then FLA, and then it found everything that I've typed already, all the commands I've sent. So there's the query one. Again, shortcuts. Shortcuts are great. Hit there. And now we see we got our UUID. Everything's good, but now it's saying the application is Klipper. So that's confirming we have Klipper installed and we're good to start setting it up and actually get going to using it. So now is the final step. Final couple steps, I suppose. This is getting your UUID set up for your main cell or for your Klipper printer configuration file. So let's get into that. Okay, so now we're here in main cell. So as you can see, there's an MCU is unavailable, blah, blah, blah. Things aren't working. That's because I don't have my hardware plugged in completely. Go to the hardware. So I don't have this board plugged in. So let's plug that in just so I can get all the errors going on. This one is plugged in at the moment. This one is the one I've been using for my tutorials. So there's nothing new here. It's being used by USB serial communication. So that's all set up. So now we have Canbus running to this guy, and then standard USB communication to this guy. This is not connected to anything. Get that out of here. So that's how we got this set up. Let's just do the restart, and it should find the board now that it's plugged in, hopefully. Yeah. Now main cell and Klipper are happy. Everything's working. But if we come into the machine zone, you'll see we only still have the SKR board and the host computer. So there's nothing else being connected right now. We have to get that set up. So what we need to do is make a new configuration file. If you follow my previous videos, you know I like to make separate configurations for each new thing. So we'll go ahead and create a new file. And let's just name this Hermit Crab. And then the important part, the name can be whatever you want. It's just important to remember what you named it because we need to include it somewhere. But the most important part is that it's ended with .cfg. The .cfg tells Klipper that it's a configuration file and be treated as such. So there's the Hermit Crab.cfg. We'll do create, and there it is. It created it, but of course it's empty. So we need to put something in there. And we have the lovely option of coming into Bitrate Tech's site. This is their GitHub. The Bitrate Tech GitHub into their Hermit Crab repository, Hermit Crab 2, and then they have a sample configuration. So they've done most of the guesswork for you. They've set up basically all the pins, all the generic stuff for getting this board to work. So you don't have to worry about doing your pins. Of course, you can always go to the user manual in here and look at that. Or let's see, I should have it in here also. You have your pins. So you can see in here, and this is also in the user map. So you can see all the pins and where everything's plugged in. But because they have their configuration already set up, all we need to do is come over here, copy raw file, and go back to our file that we made and paste that in. And one more thing we need to make sure is that the UUID is used. So you see right now, it's set up as serial. That would be if you set up for some reason as USB. Now, we want to point out you can technically do USB communication, and if you don't want to mess with Canbus and have that. But the downside to that is you will still need to run power cables to that other power port, because USB will not power your motor and hot end and all that good stuff. But you can do that if you put 24 volts to the board and a USB cable. You could do it that way too. That's an option. But we're not. We're keeping everything in one cable. So we're going to hash out that, comment it out, and then remove this one here, which says Canbus UUID. And we're going to put our UUID that we got from our query. Copy that over there and get rid of that one and copy in or paste in the new one. So that's our new board. So if everything is correct in the configuration here, we can do save and restart. Sorry, don't restart yet. Do save and close. We do one more step we have to do first. Because we made a separate folder, we have to include this folder into the printer config. So we come into here. You see I got all these different includes, right? Let's make a new include with the open and closed brackets. Include space and then the file, whatever that file name that you just made. We called it Hermit Crab here. hermitcrab.cfg. All right, so now when Klipper restarts, it'll look in here and say, okay, include that file, and it'll pull all the configuration stuff into here in the background. The reason I recommend doing it like that, because it just keeps all of this tidy. If you think about it, for instance, this one has all the SKR board stuff that I have set up. So if you were to have this and then also include all of your Hermit Crab stuff too, you can see how this file will start getting very long and very difficult to navigate. So that's why I say to use include. It's just easier. So now that you have that include and you have this file set up, save and restart. And hopefully, if everything is right in the configuration file, it should reboot and get going. Let's see. No, we got an error. Unknown. Okay, this is good that we got this actually, because this is a configuration error. This is not an error as in that the chip's not working right or the board's not working right, but this means that something is not named right. So chip name, somewhere something is calling a chip called HC2, and we've never defined a chip called HC2. And I think I know where that is, being that it's HC. I'm assuming that's Hermit Crab 2. So let's go into the Hermit Crab configuration. So what I'm talking about is this MCU is called Hermit Crab 2. And you can see when I highlight that, all of these things are highlighted. So anytime you want to define a pin on the Hermit Crab board, you have to use first the name of whatever MCU it is, and then the name of the pin. So you have the Hermit Crab 2, and then the colon, and then the pin number. So that's important. So what's going on somewhere, and I would assume in this file, instead of having Hermit Crab 2, they just put HC2. So let's find that. So you can do Control F, and it'll bring us up an option to do find. So let's do, what was it, capital HC2? And then hit next. Let's see where that is. Yes, look at right there, the NeoPixels. So they set up the NeoPixels to look at a chip called HC2. Well, that doesn't exist. We're calling this one Hermit Crab 2. So I can go ahead and copy that and then replace that. Paste. Now that's right. I'm glad actually that error came up, because this is a common error that people have when setting up multiple MCUs, is the naming issue. This is the way that you tell which MCU to look at to do a pin, because otherwise it's just, if you don't put anything there, it's going to assume the main MCU, which is like your main controller board. In this case, it would be this board. So if I were to put no number here, or sorry, no name, and just GPIO 26, well, that doesn't exist here. So you'll get that error also. So you do need to have that Hermit Crab for talking to the Hermit Crab. So let's reboot that, see if that was the only error. Save and reboot. Get any other errors? Actually, I think we will. We're probably going to get a error for temperature. Maybe not. No. Looks like we're good. That's interesting. Okay. So anyways, so we have our board. So we got our Hermit Crab 2 right here. We got our regular SKR Mini, and of course our host that is running on the BIQU. So now everything's communicating. We're all good. And technically you're set. You're ready to go. Now it's all about configuration to get your thing set up. But that is working. Everything is plugged in and working. So if you know how to do all your configurations, you're good to go. That's the video. But I will show you really quick, because I'm not going to go in. I did another printer configuration video, and this is more or less the same thing. We're just going to be doing it in the Hermit Crab. And so we'll do a quick breakdown of what's here. We have our temperature sensors for the onboard temperature sensor. So this is telling like what the Hermit Crab temperature is. And then we have, this is the accelerometer, and it actually looks like it's missing. Yeah, it's missing accelerometer information. So I have another video I can link up in the description, or actually maybe a little card that floats up here. It's how to do your input shaping stuff, and that'll go with this. But basically, you have to have some other information underneath there to actually use this chip. But right now, it's just defined. So you do have to put shaper input stuff like that. But anyways, you got your extruder thing here. So it tells it's using a generic standard temperature sensor on there. So you can program it for other things. Like I mentioned, the PT100. So there's more information on that. I'm not going to go over that because it's a little bit out of this video. As a matter of fact, here it is right here. That makes it easy. This is for if you're going to be using the PT100 sensor, you would do this. So you uncomment that, and then you comment out this part here, these two lines, and open up these ones instead. That's good. They included that. Also, you want to make sure rotational distance. This is your extruder stuff. So this looks like it's pretty much for an H2 extruder, if I'm not mistaken. That might be a little bit more. But anyway, so you're going to want to make sure that your rotational distance, that's how much the filament's going to be put out when you command it to. All that good stuff. So this is all the basic configuration stuff. You got your 2209 set up. Make sure, depending on what motor you have, that you have the right run current. This is for your fan. Fan is your part cooling fan. And then you have hot end fan and other generic fans. So these are other fans you can set up for, like your hot end fan is typically used for cooling of the heat break area. And then you have your other one is just for whatever else you want to use it for. RGB, right now, they're not really set up to do much here. They're just defined. So you can use the hot end RGB command somewhere else to activate them. So there's more to set that up if you want to. Basically, you're gonna have to put in like initial state and things like that. Here, do a quick pause and I'll put this in. Okay, so I went ahead and just put that in real quick. The magic of film and come back. So basically, what we did, this originally was only set up so you know what the pin is, but we need to use it, activate it, right? So I added these lines, and this is telling the color order of the LEDs. Actually, I did one thing I missed. Let's double check here. We need to get the this here, chain output. This tells it how many LEDs there are, because this one has 2 LEDs. So you don't want to do just one. The chain count tells how many LEDs are on there. There's 2. There's 2 neopixels. Actually, that would be 6 LEDs in this case. But yeah, anyways, two chips. And then we have these 3 colors, red, blue, green, blue, whatever. This is the intensity that they're going to be set to when you first start up, the initial light. So if you want them off when you first start, you just leave them 0. But if you want them on, say for instance, you want to turn it red, you control this by giving it an integer of from 1 to 0, basically. And 1 will be 100%, but anything after the point will be a percentage. So if you want 50%, you do 0.5. If you want 20%, 0.2, right? Anything over 1, so if you were to put 2, that's not a proper value. It has to be 1. Even 1.5 is not a proper value. 1.0 is the max. That's 100%. All right. I never recommend, or I recommend to never run them at 100%. They can, but it just gets hot. There's really no reason to drive them full. So 90 or 80% is probably the max I would recommend, or I normally use. Just make sure LEDs last longer. It doesn't heat things up. But this is going to be each one of those individual LEDs inside the chip of how much intensity. So if you want to mix colors up, that's how you do it here. So we can do something like that with, leave that 0 and then yeah, we'll just turn them on to red, see how that works. So when we reboot, I can't remember which, we'll see now when we turn it on. But these three here, these letters here is which order they come first. So it could be GRB or RGB. It depends on how the chips are designed. And so if you get, for instance, right now we're telling only red to turn on, but if it turns on green, then we know that it needs to be swapped over. So I'll show you that, make sure to see what happens. So let's go ahead and restart. And then I'll go over to the Hermit Crab here. When it reboots, it should flip on the LEDs. Yeah, there we go. And we got red. So that's the right configuration. There we are with red. And then if we go back over to here, let's see, actually, I think let's do a quick little, so you can see both going on at the same time here. All right. So to change colors, now that we have a defined LED, we can come down here and we see here's our hot end RGB. And it's now set to red, 0. This is like I was saying with those amounts, they relate to the intensities, to a different code number here. So 255 is max, 0 is minimum. But you can just easily use the wheel, and there we go. Now we got blue and green and so on. We got all the different colors of the rainbow in between. So you can change all sorts of fun stuff. So that's what those things are now. All right. So that's working good there. And again, like I've said, if you want to have a default color that it always turns on right when you start your machine up, then you would hard code that in with, where do they go? Here. You hard code them in there. So instead of red, you want blue. Restart. And once it reboots and connects, it goes blue. That'll be the default color. Those are just different ways. Now, what's really nice with Klipper is that you can set up all sorts of different macros, and every time something happens, you can actually make these things change color. There's ways of doing it where like it'll vary from blue to red as the hot end's heating up, and all sorts of fun stuff. So you just have to code that in. There's a lot of macros you can find online. I'm going to be going over macros. I know I keep saying that in my videos. I'm going to be doing that once I get some more good hard knowledge on it so I can describe it to you guys well. But yeah, so that's the LEDs working. Anything else in this machine configuration you need to go through? Your LEDs, BL Touch information. If you have a BL Touch you're doing, you're good there. If you're using the microprobe, there's more involved. I did do a video on that, so you can just do the quick drag and drop and put in there. The most important part is when setting up the pins, like I mentioned, is you have to do that Hermit Crab and what pin it's on. Because BL Touch and microprobe are defined differently. Anyways, you got some other stuff. So you got an IC square capability, which is really cool. So this allows you to add other heat sensors, temperature sensors. I'm not sure how far in depth Klipper allows, but I know like little tiny screens can be controlled with I square C. I say IC square, I2C. There's a lot of different things, little sensors and small things that you can run off of these things. So it's pretty cool that they added that option on this board, because that's not normally an option, but it's becoming more prevalent now, especially using for temperature sensors. I think it's called like a DW218 or something. I can't remember what it's called now, but some sort of like little temp sensor for monitoring chamber temperature, for instance. That's cool that they have that, but general use, not everybody's going to be using that. I just want to point that out, what that is. But it's hashed out, it's not activated. So that's really the gist of it. That's the Hermit Crab. That's how you set it up. That's how you configure things. That's how you get the LEDs working. All sorts of fun stuff. All, you know, really basic when it comes down to it. If you know how to configure your files, you're good to go. And yeah, hopefully this video was really helpful. If you have any questions, always welcome to put them down in the comments. I try to help out as much as I can, help you problem solve, all that good stuff. I know my videos are long, but this is all about teaching you how to get it to where you're not having to just copy paste things and remember what website to copy and paste from. But when it comes to troubleshooting, you know now you have the tools on how to actually figure out what's going on with these different things and how to get them fixed. So that's what's going on. I think I'm going to keep that format as long as possible, unless you guys hate it. I don't think you do, because it seems like I keep getting good notes. So I love all the comments. Thank you for all that. That really makes it, you know, helps keep me making videos, because it makes me feel good that I'm actually reaching out to people and helping them. So that's the way it is. Again, a huge thank you to PCBway for sponsoring this channel, this video. Also, oh, I forgot to mention, BigTreeTech sent me these Hermit Crab to play with. So I did not buy those. I did want to point that out, but they did not tell me I have to say anything. They didn't, they just, hey, they just reached out and said, you want to try these out? I said, yeah, of course. I had the original Hermit Crabs, as you may know with my previous videos on my channel. So I was very happy to go ahead and test these things out and play with them. And I'm going to be installing this. I think actually I'm going to install this one on my Voron machine that I just recently built. There's more in the future on that machine too. So if you're interested in that, keep watching, get subscribed if you're not. And yeah, I'm going to cut this video now because I think you guys get the gist of it. Until next time, get out there and go make something. Thank you for watching.